All right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video, and I'll go over the correct answers. So for the factoring, you can actually take out a 3 from each term. So you're not going to do remove, replace, reduce. You want to factor out your greatest common factor. And so you're going to have x squared plus 2x plus 1. And then what's left in the parentheses will factor as x plus 1 times x plus 1, which you write as 3 times x plus 1 squared. And so that'd be your answer. For the math knowledge question, the dimensions of the picture. They tell us that the frame has a 1 7/8 inch width. So the height here is 25. Well, we have 1 7/8 on this side, and we have 1 7/8 on this side. So we have to subtract 1 7/8 from 25 2 times. So 1 7/8 plus 1 7/8 is going to be 3 3/4. So 25 minus 3 3/4 is going to leave you with 21 1/4. So if you look, that goes ahead and tells us that it looks like E may be our answer because that's the only one that has 21 1/4. But let's check and make sure with the other side. So we have 20 1/2, and we again need to subtract 1 7/8 twice. So that's 3 3/4. And so if you subtract those, you will get 16 3/4. And so E is your answer. Okay, so now we're going to look at lesson 78 today. We're looking at rotations. So hopefully after this lesson, you'll understand rotations. So rotation is a transformation that's about a point. You take your figure and you rotate it about some point. The center of rotation is the fixed point about which your figure is rotated. So in our figure, our picture down here, our figure is rotated about point R. So R is the center of rotation. The rotations are assumed to be measured as a counterclockwise turn unless otherwise stated. So you go counterclockwise unless they tell you otherwise. So which way is counterclockwise? Well, look at the clock. The hands are going this direction, so counterclockwise is the other direction. A rotation is an isometry, so that means that the pre-image and the rotated image are going to be the same shape and size. So you have congruent figures, they are just turned a little bit different. If you have a point that is rotated 90 degrees about the origin, and so that means that it's counterclockwise, your point xy becomes negative yx. If your point is rotated 180 degrees about the origin, then your point xy becomes negative x, negative y. Now, 180 degrees, it doesn't matter if you go counterclockwise or clockwise, because you're going to end up in the same spot either way. Think about if you want to turn 180 degrees. So you are facing the front of the classroom. If you want to turn around, and you turn 180 degrees to the left, or if you turn 180 degrees to the right, either way, you're still going to be facing the back of the classroom now. So that's why it doesn't matter if you go counterclockwise or clockwise when you turn 180 degrees. If your point is rotated 270 degrees about the origin, then your point xy goes to y negative x. And then if you rotate 360 degrees, you are back at what you started with. So that's why there's no formula for it. It's just whatever image you had to start with. You do want to learn these. They make it so much easier if you know these whenever you go to do rotations. So on xy, when it's 90 degrees, it becomes negative yx. For 180 degrees, negative x, negative y. And then 270 is y negative x. So you want to learn those. It makes it so much easier if you already have those in your brain. If it's rotated 180 degrees about a point AB, then the formula is 2a minus x, comma 2b minus y. So if it's rotated 180 degrees about some random point, not the origin, then you do 2a minus x, 2b minus y. Okay? So let's look at an example. So if y'all would like to get some graph paper, y'all can get some, or you can do it on little graphs that are at the front. It doesn't matter to me. So we're going to graph A, 1, 2, 3, and then down 4. We're going to graph B, and then we're going to graph C, so there's our triangle, and then we want to rotate it 180 degrees, and it says counterclockwise, but again, that's redundant because it doesn't matter if you go 180 degrees. So that transformation is to take our x, y, and what do we do to it? We make it negative x, negative y. So this point for A prime is going to become negative 3, positive 4. Because we negate our x and our y. Our b value, b prime, is going to become negative 4, 2. And then c prime is going to become negative 1, 0. So if we graph A, we have A prime here. And then for B prime, and then for C prime. And so there would be your figure. And if you want to look at your paper, just turn it 180 degrees and your figure still should line up. Okay? So that's how you do a rotation. Looking at another example. This one is to rotate the point 90 degrees about the center of rotation of 5, 1. So I'm going to put 5, negative 2 here. And then we're going to put 5, 1. And we want to rotate it about this center. So this is our center. And we're going 90 degrees. And if it doesn't say which way we rotate, that means that we rotate counterclockwise. So that's going to be going this direction, off this way. And so this one is 1, 2, 3 away from the center. So when it turns 90 degrees, it's going to end up over here, and it's going to be 3 away from the center. So we were at 5 here, so we're going to go 3 more over. So that's 8, and it's going to be up 1. So the center, when it gets rotated, it's going to become 8, 1 for the point. Okay, and now we're going to rotate the point 3, 7. 180 degrees about the center of rotation, negative 4, 6. Now on this one, we can actually use our formula. When we have our point x, y, it would become 2a minus x, and then 2b minus y. This is our x and our y, and then our center is a and b. So we would have 2 times negative 4 minus 3, which is going to be negative 11, and then we would have 2 times 6 minus 7, which is going to be 5. So our point would be negative 11, 5. Okay, so on that one we didn't have to use the graph, but if you wanted to, you could. You could say 3, 7, and then it's going about the point -4, 6, so it's over here, and you want to rotate it, and it ends up over here somewhere. And so if you want to do that, you can. It would be on a straight line, so I probably didn't draw it quite well. It's going to be the point somewhere over here, where this distance is the same as this distance. So you can do it on a graph if you forget this formula, but I just think the formula makes it quick, and you don't have to worry about accidentally miscounting something on your graph. So looking at this example, we have a roller coaster loop. Find the size of the angle a car sweeps out, rotating from J to J prime. And if you'll notice on the picture, it doesn't have a prime here. There should be a little prime here. So we're going from J over to J prime. Okay, so the angle of rotation that we would have there, well, we have 1, 2, 3, 4, 5, 6, 7, 8 sections, and we went through 3 of them. And so 3 out of 8 times 360 is going to be 135 degrees. And so that would be the angle that it sweeps out in its rotational path from J to J prime. Okay? So let's see if you can do the practice problem. I'll pause it and then try it by yourself, and then you can unpause it after you get finished. So we're going to have -2, -3. We're going to have 1, 1. And then we're going to have 2, -1. And so that would be your triangle. Okay, and then you want to graph the image after a 90-degree rotation. So whenever we have a 90-degree rotation, and since it doesn't say, it is going to be about the origin. If it doesn't specify, then you go about the origin. So that would be -yx. So that's the formula that you're going to use for each of your points there. So for our A, we have -y. So our y value is -3. So A prime, -3 is going to be 3. And then our x value is -2. So that would be our A prime. For B prime, we have -y, so -1, and then x. And then our C prime, we have -y, so that'd be 1, and then x would be 2. And so now we graph those. I'm going to do it in a different color just so you can see it a little bit better. We'll have 1, 2, 3, 1, 2. Then we'll have -1, 1. And then we'll have 1, 1, 2. And so that would be your rotation. And so sometimes they're a little bit harder to tell if you rotated it correctly. That's why you want to use the formula, because I doubt that most of you would get this correct without using the formula if you tried to do it just based off of looking at it. There are some people that can do it just by looking at it, but for the most part I found that if you try and do it just by looking at it, it won't work quite very well. Okay, and so these are the coordinates of your triangle, and so it said to list them, so you listed them, and we graphed both. So that would be your answer for that one. For the next practice problem, we want to graph triangle DEF. So we're going to do D 0, -2, E 1, 0, and then F at 3, -1. Find the coordinates of the vertices if it's rotated 180 degrees about the point -1, 1. So that's when we're going to use our formula to transform xy. We're going to go 2a minus x and then 2b minus y. And our a is going to be -1 and our b is going to be 1. So for d prime, we would have 2 times -1, so -2 minus 0. And then for b, 2 times b, that would be 2 minus -2, so that's going to be 2 plus 2, which is 4. For e prime, we're going to have -2 minus 1, so -3. And then 2 minus 0 is going to be 2. And then for f prime, we're going to have -2 minus 3, so that's -5. And then 2 minus -1, so 2 plus 1 is going to be 3. And so those are the vertices, and that's actually all it asks for. But I am going to get you to graph it just so that we can make sure that it does look right. Because you want to make sure that you graph it and that it matches up with what your vertices have, just so that you make sure you didn't mess up on multiplication or subtraction or addition somewhere in there. And so this would be d prime, e prime, and then f prime. Now, if you look at it, it may not look right, but you've got to remember that our point of rotation was -1, 1. And so now, if you look at it, hopefully it does look like it got rotated correctly. Okay, so looking at one more practice problem, we've got the rim of a tire to the nearest degree. Find the angle of rotation required for spoke A to move counterclockwise to position B. So counterclockwise is going this direction. And so if you look, we have 1, 2, 3, 4, 5, 6, 7. And ours is going 5 of those. So we are going 5/7 of 360. And so if you multiply 5/7 times 360, you should get approximately 257 degrees. And so that would be your answer there. Okay, so now we're going to look at the challenge questions. We have the coordinates for our figure, or we have the figure MNOPQ, and we want to rotate it 270 degrees counterclockwise about the origin, and they want us to give the new coordinates. So y'all try that one, and then after you finish, unpause the video and you can check and see if you got it right. So that's when we're going to use the formula to transform x, y. We're going to go to y negative x. So m prime is going to be -2, -1. N prime is going to be 1, -4. O prime is going to be 3, -3. P prime is going to be 3, +2. And then Q prime is going to be 1, 2. And so that would be your answer for the challenge question. So maybe some of y'all got that correct. Hopefully so. Anyway, that is how you deal with rotations. So I'm going to go back real quick. You want to learn these. You definitely want to learn those 4. Okay? If you don't learn those 4, then it's going to make it really hard to do these. So your homework is due tomorrow, 1 through 30. So you need to make sure to do those tonight so that we can go over any questions that you have tomorrow.